I'm going to do a video on irrational numbers. Now, you may have just watched my video on rational numbers, and you might be wondering, well, if we know all about rational numbers, why do we have to care about irrational numbers? And the reason why is because the real numbers, all the numbers that we actually know, that we use, are broken into two groups. And those groups are rational and irrational. And right now we know that something like 3, 6 over 2, -5, 13 quarters, 3.8, I'll say -3.8, these are all rational numbers. So what on earth is an irrational number? Well, my last video I said that 1/3 is a repeating decimal, and it's 0.3 repeating, and that's why I put this little bar on top. This little bar here just means repeats. Well, if we had a decimal that didn't repeat and just went on forever, so if I had something like 0.28691143287, etc., and it went on and on and on forever.
I hear you when I go to the toilet.
You scared me very much. Great. I'm doing
Daddy,
some.
I
This.
want to wipe this pink white something.
Go get changed then. Go get changed. So this would be. Sorry for that. This would be an irrational number. Now, you can tell it's irrational because it does not. It does not repeat. And by it, I mean the decimal. It does not repeat. And it does not end.
Daddy, I think I need help because this is so hard to get on. So hard to get off.
So the problem is how. Why? What would the irrational number look like? I'm sorry, I was just hoping my door would get changed. So what would an irrational number look like? Well, there's certain irrational numbers that are very easy to identify, and the most important, or not, I shouldn't say most important, the most famous is pi. And pi is approximately 3.141, etc. It goes on and on and on. And if you go to your calculator and you type in pi, type in pi, you will see it goes 3.14159. It goes on and on forever. It doesn't repeat. Well, there's other numbers as well, such as the square root of 2. And you can see this looks like it starts to repeat, but it doesn't. The square root of 3 is 1.7, and this, once again, it does look like it repeats, but it won't. Something interesting happens when it gets to the square root of 4. You get 2. And the reason why is because the square root undoes a square. For all intents and purposes, we're going to say that's true. So let's take a look. 1 squared equals 1. 2 squared equals 4. 3 squared equals 9. So if you take a number between 1 and 4, like 2 or 3, and you put them under a square root sign, those will be irrational numbers. If you take a number between 4 and 9, you will get irrational numbers. They go on and on and on forever. They never repeat. They never end. If you go to square root of 9, the square root of 9 is 3, which is, once again, it's a rational number. This is a rational number. And that could go right in here, square root of 9. Pi was our most famous one. And so you might be saying, well, how do I know which ones are going to be perfect squares? If I had 4 squared, that's the same as 4 times 4, which is 16. So anything between, and 3 squared was 3 times 3, which was 9. So any of the numbers between 9 and 16 will be, the square root will be irrational numbers. There's one last thing I want to say before I end this video. The square root of I'm sorry, negative the square root of 10 is irrational. However, the square root of negative 10 is a whole nother ball game, and for 7th graders right now, you don't need to know about that. But just remember, you can never have a negative underneath the radical sign, the square root sign, unless it's something like this. If you had something like 8 minus 2, because this would be order of operations, that's the same as the square root of 6. Alright, that's it. Hope this makes sense. Bye-bye.